Okay, on this video we are going to see Laplace transform when the function is not given, well, it's given through a plot, right? So we have to make the Laplace transform of this function, which starts in 1, then goes down in 1, and x equal to 1, and then is equal to 0. Now this is a composite function. If we write like this, the composite function like 1 minus t, which is this part of the plot, and that is between 0 and 1 in the time. 0 between 1, okay? And then it is 0 when t is greater than 1. So here, how can you check that this is the function? Well, if you replace the value of t equal to 0, you get 1, okay? And if you replace the value of t equal to 1, okay, 1 minus 1 is equal to 0. So this is the plot. Alright, so this problem is requiring to make the Laplace transform of this function, but it is a composite function. Because we don't have a formula for that, what we have to do is apply the Laplace transform definition. And the Laplace transform definition is the integral from 0 to infinite exponential minus st, and then here f of t. Remember, whatever you have here goes here. Now let's split this integral into integrals. What I'm going to do is to split the integral in this section and then in the rest of the section. So what I'm going to do is make the integral from 0 to 1, which is from here to here, exponential minus st, and then f of t, differential of t, and then plus the integral from this section from 1 to infinite, exponential minus st, and then f of t, differential of t. Now, okay, so what we have done is just make the integral from on this part from 0 to 1 here, and then from 1 to infinite. Now the advantage to do that is that the function of f of t between 0 and 1 in the time is equal to 1 minus t. And then the integral from 1 to infinite of the function, and the function happens to be 0. So this is 0. Because this is 0, then the integral is equal to 0. There is no area under 0. Okay, so the only thing left is this part of the integral. So let's do it. So it's going to be the integral from 0 to 1 exponential minus st, and then minus t exponential minus st, and then differential of t. Now I have made a multiplication of this times this and this times this. Okay, so what we have to do is to integral from 0 to 1 exponential minus st, differential of t. This is this part, and then minus the integral of t exponential minus st, differential of t, from 0 to 1. Okay, this one is very easy, but we have to complete the integral minus s or minus 1 over s here. Okay, this is done. Okay, this is just the result of this is just minus 1 over s exponential minus st, and then we still have to make the evaluation from 0 to 1. Now the other one, what we have to do here is integration by parts. So let me do the integration by parts over here. So what I'm going to choose is u equal to t, so differential of u is equal to differential of t, and then the rest, differential of b is equal to my exponential minus st, differential of t. So that means that the b is equal to, you take the integrals on this, you have to complete this integral, minus 1 over s exponential minus st. Okay, if we apply the integration by parts here, it's going to be minus, so this is here, u times b minus t over s exponential minus st, okay, u times b, this is from 0 to, no, from 0 to 1, and then minus the integral of b, differential of u, minus 1 over s exponential minus st, and then differential of t from 0 to 1, and this is just this part. Okay. Okay, so let's evaluate this integral. Well, this upper limit minus the lower limit, minus 1 over s, and here is going to be exponential minus s 1 minus exponential of 0, okay? The upper limit minus the lower limit, and then minus times minus, positive t over s exponential minus st from 0 to 1. And then this integral is going to be minus times minus times minus negative 1 over s, and you have to make minus s here, and you have to compensate 1 with 1 over s. So this becomes 1 over s squared. And negative, because you have a negative, then this becomes positive, minus. Now this minus 1 over s, this comes from this integral. Now the next minus 1 over s comes from the integral of here. What I have done is just taking this outside. Okay, 1 over s squared exponential of minus st from 0 to 1. Okay, now exponential of 0 happens to be just 1, exponential minus s is like that. And here let's do this evaluation. Okay, so this is going to be equal to minus 1 over s exponential minus s, this one minus 1 here, and then here is going to be plus the upper limit 1 over s exponential minus s, that is the upper limit, minus the lower limit 0 exponential of 0 over s. Now this clearly goes to 0, and then plus 1 over s squared, and then this exponential minus s minus exponential of 0, exponential of 0 here, so this is clearly 1. Okay, so what is the result? The result is like this. The Laplace transform of the function, the original function, is the result of this, minus 1 over s exponential minus s minus 1, and then plus 1 over s exponential minus s, okay, and then plus 1 over s squared exponential minus s minus 1. Now I can see that this and this happen to be the same, so they cancel except for this. So the result is just 1 over s minus times minus positive, and then plus exponential minus s minus 1 over s squared. So that seems to be the result. Okay, now this is how you resolve this kind of the Laplace transform. One of these is on the comment. So this is just how to show you how to solve it. All right.